Okay, so here are the notes of section 2.8. Basically, it's just me running through all the theorems and you answering questions about it throughout the form and then writing them down yourself. We'll go through and prove some of these in class tomorrow or today, whenever you're watching the video, I guess. Um, and then we will apply them in some examples. So again, all about angle relationships. So we had a little theorems yesterday about segments and problems about segments. Now we're going to do it with angles. And a lot of it's going to feel similar, but there's more theorems, so we're going to have more work to do. So the first thing is the protractor postulate. And just like the ruler postulate, the only reason this really exists is because this is how we basically say, hey, we can measure things. We can throw, we could say A is at 0. We can say C is at 145. So this angle here is 145 degrees. That's all it's for. Is like, how do we measure an angle? Well, you can give A a value, C a value, and then give a measure. The angle addition postulate, this works just like segment addition postulate. That, hey, if you've got two angles and there's a point between, okay. So let me actually just go to the video here. So, oops, wrong switch. I keep hitting the wrong thing. So in this one here, you've got two angles. You've got you've got X, which we'll put that in blue. Okay. That's ABD. And you've got BDC, the Y, in red. The only way D is between inside this angle is if the two parts add up to be the whole length, which, again, hopefully that's kind of like common sense that, oh yeah, this part, this angle here, plus this angle here, they add up the same thing because they are adjacent angles. All right, now, next theorem is actually a theorem we've used, really not a theorem we've used before, but a problem we've done before. It's the supplements theorem. And the supplements theorem states that if two angles form a linear pair, then they're supplementary angles. The complements theorem is similar. I mean, supplementary means adds to 180. Complement means adds to 90. So the complements theorem states that if two angles have non-adjacent sides, or non-common sides of two adjacent angles, form a right angle, then the angles are complementary. So if I go to this, if I kind of go look at the drawing here again, hopefully this seems kind of obvious. So what I've got is, okay, first of all, for the supplements theorem, this angle here is a straight angle. A straight angle is 180 degrees. A line is always 180 degrees. So that should be obvious that 1 plus 2 has to be 180. But also if you think about it, let's say I make up an angle measure for 2. I don't know, angle 2 is like 120 degrees. Okay, if it's 120 degrees here, if it's going to make up a line, the rest of it has to be 60. So yeah, if they're a linear pair, they're going to have to add to 180. So hopefully that's obvious. We'll use this theorem in a few specific places, though that's why it's so important. And then the non-common sides. Okay, so here's basically what we have. We have two adjacent angles that form a right angle. So more importantly, the first thing you have is you have a right angle. Okay, that's it. We have a right angle. And then we're going to throw another weird angle in here in the middle to make it adjacent. Well, again, the whole thing is 90, so this part plus this part has to be 90. So if this is 60, that means it has to be 30. So we're just saying these two angles have to add to 90. So the supplements theorem and the complements theorem, hopefully they seem kind of obvious because they're not meant to be super complex. We'll use the complements theorem occasionally. Really, it's the supplement theorem we're going to use, if anything. We'll see an example specifically where we do use that in class. Reflexive property, symmetric property, transitive property, they're all back again. We will use transitive property quite a bit in this section as well. Reflexive, some in chapter 4, symmetric, not really. It's just, again, reflexive, anything is congruent to itself. Symmetric, you can switch the order and you're fine. Transitive, if two things are equal to the same thing, they're equal to each other. Right. The next two are the congruent supplements theorem. Okay, and the congruent complements theorem. The congruent supplements theorem we will use a ton. It feels like in this section. We're actually going to use it for the next theorem to prove it, which we'll go over in class. And it really works a lot with the supplement theorem. So theorem 2-3, which we're not going to call it 2-3, we'll call it the supplement theorem, or we'll just write it out if two angles form a linear pair, then they're supplementary. And the congruent complements theorem we will use together specifically in problems. And what the congruent supplements theorem says is this: angles supplementary to the same angle or two congruent angles are congruent. So And then the congruent complements theorem says angles complementary to the same angle or two congruent angles are congruent. Now what a lot of people do with this is they get it mixed up. They think it's like the transitive property where, oh, two things were congruent to the same thing, therefore they're equal. This is saying two things are supplementary to the same angle. And people would think that means, oh, they must be supplementary then. No, they're not. If two angles are supplementary to the same angle, they're congruent. If two angles are complementary to the same angle, they're congruent, and let me show you how we can kind of figure that out real quick. So I'm going to make up two angles. I'm going to say angle 1 is like, I don't know, it's obtuse. I'm just going to make up a number that's obtuse. I'm going to say 130 degrees. Well, here's what I know. Angle 1 and 2 are supplementary, because that's what we're told. Angles are supplementary to the same angle. So I'm going to say angle 1 and angle 2 are supplementary, which hopefully you can see because they're like a linear pair that's split up. Okay, if I could just pick two up and slide it over, they'd make a line. So that means it would be supplementary. So angle 1 is 130. That means angle 2 has to be 50 because they have to add up to be 180 together. So if angle 1 is 130, angle 2 has to be 50. Now I said that angle 2 is 50, and I know it's also supplementary to angle 3 because if I turn my drawing here, they look like they make a line, which means they have to add to 180. Oh, well, if this is 50, in order for those guys to add to 180, this has to be 130. Oh, these two guys are going to have to be equal. So again, that's a lot to unpack, but the key is if two angles, 1 and 3, are supplementary to the same angle, angle 2, that means 1 and 3 have to have the same measure. Okay. Same thing for 2.7, the congruent complements theorem. I'm going to work this the same way. Now it's just they're complementary angles. So I know that angle 4 and angle 5 are complementary. So if angle 4 is 30 degrees, that means angle 5 is 60 degrees because they have to add to 90. So this is 30, this is 50. I also know that 50, oh, here's 5. It's sorry to say 50, I meant 60. Ugh, you're going to catch that and tell me that I made a mistake. So this is 60 and this is 60. Well, if 6 and 5 are complementary, hey, if this is 60, that means there has to be 30 left over for 6. Hey, look at that. 4 and 6, they must be congruent. Okay. All right, so again, we'll come back and talk about these in class, definitely, because we're going to need the congruent supplements theorem. Now, the next three, the next theorems, okay, are hopefully a little bit more obvious. Vertical angles theorem, we've already talked about this, vertical angles being congruent. I'm telling you right now, we're going to come back to this and we're going to prove this in class tomorrow because this is one of these things that if you have taken geometry, you should see the proof for this. You should be able to verify it because we use vertical angles in this section. We use them in chapter 3. We will use them in chapter 4. We'll use them in chapter 5. We're going to use vertical angles all year long, which is why I always hammer you with the definition. And then the last theorems are the right angle theorems. And these are, for the most part, kind of, I don't want to say common sense, but hopefully they make sense that way and you can just kind of go, yeah, I take it, they're true. So the first thing is this: if you're perpendicular, okay, you intersect to form 4 right angles. Now I might say to yourself, why do you need to say 4? Well, the definition of perpendicular just states that 2 lines intersect to form a right angle, not 4. If they'd said 4, it'd be nice, but they just say 1. So we have to have a theorem that specifies, no, all 4 of them would be right angles. And I think it's kind of obvious to see. 210 says all right angles are congruent, which that should be obvious as well. If you're a right angle, you're 90 degrees. They all have the same measure, must be congruent. And then this is the weird one. It kind of pops up in random places here or there. It's almost one of those, again, that's hopefully kind of obvious. It's perpendicular lines form congruent adjacent angles. What that means is if they're perpendicular, 1's congruent to 2, 2's congruent to 4, 4's congruent to 3, and 1's congruent to 3. And again, hopefully that makes just obvious sense because they're all 490 degrees and all right angles. Theorem 212, okay, this one, again, it's not super obvious, but not crazy. Again, I think if you were like working with numbers in a drawing, you wouldn't have to think so hard. It would make more sense, but sometimes it's kind of complicated with just the words. But what we're saying is this: we have two angles that are both congruent to each other and supplementary. If that's the case, each angle is a right angle. And I'll come back to this in a second. And then 213, if two congruent angles form a linear pair, then they're right angles. So let me just, I want to show you this one with a little bit of algebra. So 212, what we're saying is this. Okay, 5 and 6 are the same. So I'm going to call them both x and x, and because they're the same measure, and they're supplementary, which means they have to add to 90. So x plus x, sorry, not 90, 180, that'd make them complementary. So x plus x has to be 180. Well, x plus x is 2x. 2x is 180. Divide by 2. X is 90. Oh, they're both right angles. So if two angles are congruent and they add to 180, basically, they both have to be 90 is what it's saying. So there's the theorem for that. And then 213, okay, two congruent angles form a linear pair. Well, here we go. We get a linear pair where they're both the same, so they're both x and x. What does it mean to be a linear pair? Well, by the supplements theorem, linear pairs are supplements, which then it goes back to this one here. Oh, well, they're congruent and they're supplements. Add to 180. 2x is 180. Divide by 2. X is 90. Okay. Now, since there were so many theorems today and they had to copy, I know it's going to take you a while to do all this. So no homework. Just have them all copied out and filled out the answers on the form. Okay, I had to fill out the questions on the form. And I'll see you in class tomorrow. Okay, thanks.